Hello everyone, welcome back to LifeFit Technologies YouTube channel, and thank you so much for watching and supporting our content. I also hope you're enjoying your Easter. So this is another episode of our Huawei Lab simulation series. Remember, in this series we demonstrate to you how to configure and troubleshoot different networking protocols or different networking technologies on Huawei routing and switching devices. So if you are interested in learning how to operate, how to manage, how to configure Huawei routing and switching devices, kindly check out these videos on our channel. And please, if you haven't subscribed to our channel, kindly hit that subscribe button to stay tuned in for more upcoming videos. So in this episode we are discussing about port address translation. So remember, in our last two episodes we discussed about the other two types of network address translation. So you have the static NATing, where you are doing manual mapping between private IP address and public IP addresses. So the network administrator has to do manual mapping between the private and the public, and that one, it's not scalable enough, and it also doesn't conserve public IP addresses, because remember, if you have 100 devices, you have to do manual mapping between the private IPs of those 100 devices, and you need to assign them public IP addresses. So that one, the workload is too much, not applicable in medium to large networks. And again, I've mentioned that it doesn't conserve public IP addresses at all. We also discussed about dynamic NATing. So dynamic NATing, you don't have to configure the mapping manually as a network administrator, but again, we are still doing one-to-one mapping. So it's scalable, but again, it doesn't conserve public IP addresses. If you have 100 devices, these 100 devices will be mapped to 100 public IP addresses. So the two methods don't conserve public IP addresses, and that's why we have the port address translation. We have the network address port translation, which will be able to map multiple private IP addresses to one public IP addresses using ports. So this is the most scalable and the most preferred type of NATing for medium to large networks, like the service or the enterprise service provider networks or the enterprise networks. So whenever you are doing network address port translation, there are something that you need to do. First thing is that you need to configure an address group. So we are configuring an address group and we are assigning this IP range. So you need to define a range. So we are creating a range of 200.200.200.10 to 200.200.200.12. Then you need to configure an SEL. So in this case, we are using a basic SEL to be able to match the source IP. So any packet that is coming in with this source IP address will be matching this SEL 2000. And then once we've configured the address group and the SEL, we go ahead and configure our NAT. And remember, we are doing port address translation, so we won't be using the no PAT command. By default, if you configure this command, then this will be port address translation. So you use NAT outbound, and then this is the SEL that we configured. We bound it with the address group, and that is it. We should be able to do network address port translation on these devices. And then we'll demonstrate how we'll demonstrate by doing some packet captures to show you that the mapping is happening just to one public IP. So let me log into the devices. So we have router 1 and router 2. So we'll start by configuring router 1. So on router 1, I'll configure the sysname R1, and then I will configure the interface IP addresses. But before I do that, let me enable DHCP. Remember, we'll be using DHCP to assign IP addresses to the PCs. So I'll run the DHCP enable to enable DHCP globally, and then I'll now do interface configurations. So interface gig 0/0/0 will assign it an IP address of 192.168.10.254. mask is 24. That is it. And I'll use the command DHCP select interface. So this router will now be able to assign IP addresses to the PCs. The next thing that we need to do is to configure the interface between R1 and R2. So I'll configure interface gig 0/0/1. IP address it's 200.200.200.1. Mask is 24. Once you've done these configurations, we need to configure OSPF. So I'll run the command OSPF. Let me just clear the screen first. OSPF 10. Route ID will be 1.1.1. And then all the routers will be in area 0, and we need to advertise the network. So the network will be 200.200.200.0. The wildcard mask is 0.0.255. So that is it for this router configuration, the basic configuration. We need to configure R2. So on R2, I will also configure the sysname to be R2, and then the interface parameters, interface gig 00, will be assigned an IP address of 200.200.200.2. Mask is 24. And again, we need to configure the other interface, Ethernet 0/0/0. I'll give it an IP address of 198.200.200.0. These ones will be .1, mask is 24. Once we've done this, we'll go ahead and configure OSPF. So it's OSPF 10. Router ID will be .2. And then it's still in area 0. And this one, I will advertise everything into OSPF. So I will use this special network and subnet and the wildcard mask 0.0.0 so that it's matching everything. Once we've done this, we should be having our OSPF neighbor relationship coming up. Display OSPF peer brief. You can see that we have an adjacency. If I check on R2, we should be able to ping the server, which is in 198.200.200.254. You can see that there is communication from this router to the server. So that one completes our basic configuration. Now we need to go back to R1 and do our NAT configurations. So for the NAT configuration, it's very straightforward. We first need to create an SEL to match the source IP addresses that are coming in with 192.168.10.0. So an SEL, you use the command SEL, will give it a range of 2000. And you configure the rule 10, permit. Then its source, which is 192.168.10.0. Mask is 0.0.0.255. That is it. Then we need to configure the address group. So the command is NAT address group 1. Then you assign the IP address to 200.200.10 to 200.200.200.12. So these are the IP range that will be used for the network address translation. Once we've finished this, we need now to go ahead and implement our NAT on the outbound interface. So it's interface gig 0/0/1. You use the command NAT outbound. You specify the SEL and then the address group 1. And then you need to click end if because we are not disabling PAT. This is port address translation. So once I've done this, I should be good to go. Let's try to check on PC1. So PC1 should be assigned an IP address and it should be able to. So on PC1, if I do IP config, you can see that it has been assigned an IP address of 192.168.10.251. Am I able to ping the server? Ping 198.200.200.254. You can see that we have communication from the private IP to the public IP. If we do some packet capture on this interface, then I filter out only ICMP. So this is ICMP and I'll do a ping. So you can see the source is 10.10.10. This is the source IP address and the target is 254. So this was on which PC? This is on PC1. Let's try on PC2. So PC2, I do IP config. You can see that it has been assigned 252. I need to ping 198.200.200.254. And this one has been assigned 11. Let's try again with the other PC and see which IP address will come in. This is PC1. We see the packet captures again. PC3, so we need to also check on PC3 just to verify that it's able to IP config ping 198.200.200.254. You can see that the pings are going through. So if I check on this router, display NAT session all, this router normally takes some time. But you can see that it's very simple to implement port address translation. So you can see the mapping. We have some sessions that have been recorded on the PC, on the router. PC2, if you ping, you also expect some sessions. 12, 11, 11, 11. So if you have another PC, let me just add another PC here. This PC, we want to, and then because we haven't done one-to-one mapping, it's just dynamic and with port address translation. So if I add the two PCs, they should also, although we have just configured only 3 IP addresses. So what I'll do is I will put a continuous ping. Let me cut it and then copy the same command. So this one the ping is going through. This one I also need the ping to continue. This one I also need the ping to continue continuously. And then this PC5 need to enable DHCP on this PC so that it's assigned an IP address. So IP config, it has been assigned an IP address ping 198.200.200.254-T. You can see that the ping is going through. On PC6, we also need to enable DHCP. Then we can ping 198.200.200.254-T. You can see that we have 5 PCs and all these 5 PCs are able to access the internet through the network address translation. Although we have only assigned 3 addresses, they are all able to access the net without any problem. And you can see that these IP addresses have been assigned, like same IP addresses have been used for the same hosts. So you have them repeating, just the ports that have been assigned will be different, but the address can be reused with multiple hosts. So the configurations are very straightforward. And this one is more scalable, of course, very applicable on networks, on large scale networks like the service provider networks, the enterprise networks, the carrier networks. They all use port address translations because we can have multiple hosts or multiple private IP addresses assigned to the same public IP addresses. So if we have two public IP addresses, we are able to serve so many private hosts, which allows the host to access the internet. So just to show you the configurations again, where is this? So you need to configure a NAT address group and specify the address range that will be used. You also need to configure the ACL to match the source IP address from the private side. And once you've done that, you need to bind the ACL with the address group or the outbound interface, which is interface gig 001, and that is it. So I hope you've enjoyed this session, and just a kind reminder that if you are yet to subscribe to our channel, kindly hit that subscribe button to support us and also to stay tuned in for more upcoming videos. Thank you so much, and see you in our next episode. Bye.